Hi guys, my name is Dr. Haslinda and I'm glad to share some knowledge about heat transfer with you. To measure your ability to learn this chapter, the chapter content was designed to furnish knowledge that you should be able to do the following attributes when you complete this chapter. Heat is the form of energy that can be transferred from one system to another due to temperature differences. Heat transfer deals with determining the rates of such energy transfers and temperature variations. The transfer of energy as heat is always from the higher temperature medium to the lower temperature one. Heat transfer stops when two mediums reach the same temperature. Heat can be transferred in three modes: conduction, convection, and radiation. For your information, energy can be transferred to or from a given mass by two mechanisms, which are heat transfer and work. And their units are in joules or kilojoules. Heat transfer rate is the amount of heat transferred per unit time. Therefore, its unit becomes joule per seconds or watt. Heat flux is the rate of heat transfer per unit area normal to the direction of heat transfer, and the unit is watt per square meters. The first law of thermodynamics states that energy can neither be created nor destroyed during a process. It can only change forms. The net change in the system's total energy during a process equals the difference between the total energy entering and the total energy leaving the system during that process. And the energy change is zero if the system's state does not change, applicable for a steady process. The energy balance for any system undergoing any process in the rate form is expressed here. In steady operation, the rate of energy transfer to a system is equal the rate of energy transfer from the system. In heat transfer problems, it is convenient to write a heat balance and to treat the conversion of nuclear, chemical, mechanical, and electrical energies into thermal energy as heat generation. A closed system consists of a fixed mass. For most systems encountered in practice, the total energy consists of the internal energy, denoted as U. In the absence of work interactions, the change in the energy content of a closed system is equal to the net heat transfer. To further understand the concept of a closed system, let us discuss example 1.1. In this example, a 10 centimeters copper ball will be heated from 100 degrees Celsius to an average temperature of 150 degrees Celsius in 30 minutes. The average density and specific heat of copper in this temperature range are given. Based on the situation, determine the total amount of heat transfer to the copper ball, the average rate of heat transfer to the ball, and the average heat flux. The amount of heat transferred to the copper ball can be determined by balancing the energy transfer to the system with the energy increase of the system, which is the change in its internal energy. This can be demonstrated through the illustrations. The heat transfer rate changes typically during a process with time. However, the average heat transfer rate can be determined by dividing the total amount of heat transfer by the time interval. It can be explained as follows. Heat flux can be determined by dividing the heat transfer rate with the surface area normal to the heat direction. Therefore, the average heat flux in this case is as demonstrated.